Hello everyone, welcome back to RAAHA VLSI. In this session, we are going to discuss about the combinational circuit designing steps. So here in combinational circuits, again as VLSI, as we already know, we'll be having two types of circuits, right? Combinational circuits and sequential circuits. Now we are having some specific set of procedure, we can say some set of steps that we can follow in order to design the combinational circuit. So in this session, we are going to discuss what are the different steps involved in combinational circuit designing. So let us start combinational circuit design procedure. Let's say procedure. So in this we are having multiple steps. The first step is we have to understand the logic. Logic we have to understand. In the second step we have to write the truth table. In third step we have to write the Boolean expressions for the outputs with respect to the input variables that we are having. Okay, so the last step is whatever the expressions that we have got, write Boolean expressions, right? We have to write the Boolean expressions, right? After that we'll be getting the Boolean expression. Based on the Boolean expression we are going to construct the circuit, constructing the gate level circuit. Okay, these are the set of steps. Here we are having 4 steps in combinational circuit designing. First one is understanding the logic. We have to understand the logic here, right? What is mean by understanding the logic? Let's say whenever in combinational circuits, when you are designing any circuit, it may be any circuit. First of all, you have to read the question carefully. You have to read the requirements carefully. In the requirements, it will be mentioned clearly that what is the functionality, what is the operation of the circuit that we are going to build, right? That we are going to construct. Now the operation or the working procedure of the circuit is nothing but the logic of that particular circuit. So first of all, understand the logic. So what are the inputs, what will be the outputs for that circuit, and what is the functionality in the sense the operation. So how the circuit is going to operate, everything we are going to understand in the first step, understanding the logic. Now in the second step, truth table in the sense based on the understanding that we have got on the logic, now we will write one truth table. Now what is truth table? Truth table is nothing but it is the truth table in which we'll be having input signals and output signals will be there. Based on the input signal values we are going to write what are the outputs for the particular, with respect to the input values, the output values we are going to write. Okay, with respect to the input values, the output values are we are going to write the output value. So this kind of truth table is nothing but the table which is representing the functionality of the circuit which we are going to implement. This is the second step for me. Now after the second step, in third step we have to write the Boolean expression. Boolean expression in the sense the output expressions actually. Okay, now in truth table, in the previous step we will be having the truth table. Now in the truth table we'll be input signals also, output signals also will be there. Now by using that truth table I will write the expressions, Boolean expressions for the output signals I will write. Now once we have got the expressions of the output, we will be constructing the circuit. That is the final step. This is my fourth step. Now let us take one example. We'll take one example of, let's say, half adder. Let's say half adder. This is the one example. I'll take one example called half adder. Now half adder is my requirement. Okay, I want to construct the circuit of my half adder is what my requirement. Okay, this is one of the example. Now first of all, understand the logic. We have to understand the logic. Now what is the logic of your half adder? Let me write the logic of your half adder. Half adder is the logic circuit. Okay, it is the logic circuit which adds, which will do, let's say, which will do addition of two numbers or values. Two numbers or values. So this is my logic. Now we understood the logic, right? This is the first step, understanding the logic. Half adder is the logic circuit which will do which will do the addition of two numbers. So this is what the logic of my half adder. Okay, now how many inputs it is going to have, how many outputs it is going to have, everything we have to understand, right? So here let us see the block diagram. Okay, the block diagram in which we will be having the idea of how many inputs and how many outputs will be there, right? Let us understand that how many inputs will be there and how many outputs will be there for your half adder. Let us discuss. Okay, so block diagram of half adder. Okay, it is just normally I am going to represent the how many inputs will be there, how many outputs will be there, simply that's it. Okay, so let's say this is my half adder in which how many inputs and how many inputs we have to write, correct? So let's say two inputs will be there. So for your half adder we will have two inputs will be there, two outputs will be there. I will name my inputs as AB are my two inputs, and my outputs are sum is my first output, and carry is my second output. Sum is my first output, carry is my second output. This is my block diagram. Now based on this block diagram I have to write the truth table, right? Truth table we have to know. If you see, we understood the logic of the half adder, right? This is the logic of half adder. This is the block diagram. We'll be having two inputs and two outputs will be there. Now how the outputs are generated? These two values, let's say a is equals to 0, b is equals to 0, means these values this half adder will add. This half adder will add these two values and it will give the sum output and carry output. Okay, fine. So after understanding the logic, we have to write the truth table. Let me write the truth table now, which is the second step for me. Okay, truth table. Okay, what is the truth table? As we have already discussed, it is a table in which inputs and outputs will be there. Let me write AB are my inputs, sum is one output and carry is another output for me. Okay, truth table is this. Which two inputs are there? So if you are having two inputs, how many combinations will be there? Four combinations. 0 0 0 1 1 0 1 1. Four combinations will be there. 1 2 3 4. Four combinations are there. So how I have calculated this in the sense by using this 2 power n formula. So in the place of n, just put how many variables, input variables are there? Two variables. So in the place of n, you have to put 2. Okay, 2 power 2, it will give you 4. Four combinations. 0 0 to 1 1. These are the four combinations. So how your half adder will do? Half adder will be adding these two bits and it will giving you the sum. And the carry condition is whenever you are adding two ones, 1 plus 1 if you do, then the carry will be 1. Otherwise the carry will be 0. So let us write the outputs over here. 0 plus 1, 0 plus 0 will be 0 with a carry of 0. 0 plus 1 will be 1 with a carry 0 again. 1 plus 0, sum will be 1, because 1 plus 0 means 1 only we are going to get for sum. For carry it will be 0. Now here if you observe 1 plus 1, so here we got the carry condition. If you observe, when we are adding 1 plus 1, the sum will be 0 but the carry will be 1. The carry will be generated when the 1 plus 1 combination arises. Okay, done with the truth table. So this is my second step. Now after that, what we have to do, we have to write the output expressions, right? Sum expression we have to write and carry expression. First of all, let me write the sum expression. So sum is equals to now how to write the sum expressions? For whatever the input combinations the sum is high, I will be considering only those combinations. So here if you see, for 0 1 the sum is 1, for 1 0 the sum is 1. So I will consider 0 1 and 1 0. So how 0 1 is written in terms of expression means 0 means a value, right? 1 means this b value. So a is equals to 0. 0 means complemented. So A bar I will write. So I will take here A bar B, right? 1 means B. So A bar B, this term is done. Now the second term, another term is 1 0. Here if you see 1 means A I will write. So plus you have to take, right? This is one term, this is one term. A bar B is one term for me, plus this another term I have to write. Another term in the sense A B bar, because B is 0. That's why B bar we will write. A B bar. Okay, done with your sum expression. So in the same way we can write for carry also. Here I will write for carry. Carry is equals to, for your carry only this, for this combination the carry is 1. So if you consider this combination 1 plus 1, 1 1. So A is also 1, B is also 1. So simply write it as AB, A and with B. So here if you see A bar and with B, or A and with B bar. So this is my sum expression, this is my carry expression. Now if you know the logic gates, we have something called XOR gate. What is the output equation of XOR gate? A XOR B, right? So if you observe in XOR gate, A bar B plus AB bar is the output equation of XOR gate actually, which can be rewritten as A XOR B, right? So now what I will do is A bar B plus A B bar can also be written as A XOR B. So finally this is my sum expression, this is my carry expression. Okay, sum expression is done, carry expression is done. After that what we have to do, let me represent the steps over here. This is my first step, right? Understanding the logic. Okay, done. After that the second step is writing the truth table, that is also done. Third step, writing the expressions, right? Third step is writing the expressions, so that is also done. Now the final step is fourth step. Now what we have to do in the fourth step, we have to construct the circuit now. We have to construct the circuit. So if you want to construct the circuit, you have to use the sum expression, carry expression. Okay, first let me construct the sum, after that I will construct the carry. Okay, sum is A XOR B. So what we have to do, we need one XOR gate. First let me take A, B are my two variables. So I'll take these two as my inputs and I will give to XOR, because here I'm having XOR operation. So I will take one XOR gate. So this is the structure of XOR gate, as we already know. This is my XOR gate. So now what this output will give? The output will give me A XOR B, which is my sum expression. Sum expression is done, generated, constructed. Now carry. Simply for carry AB, right? A and with B. You are doing one AND operation. So we need one AND gate over here. So here A is already available, right? So I will take A from here, I will drag this A and I will drag this B also. And I will take one AND gate, which will give what this AND gate will do. This is my B, this is my A. So it will just do the AND operation of the inputs for me. So A and B. So what is this? This is my carry expression. Okay, done. We have constructed the half adder circuit using logic gates. Done. Now another way of implementing your this circuit is using basic gates. Now here if you observe, we have implemented this circuitry using logic gates. Using logic gates. So logic gates in the sense, we have used basic gates also, universal and special. Okay, any gate you can use in logic gates. Now if in interviews, if you get any question like you have to construct a half adder using only basic gates, right? Only basic gates, how you can do? Only basic gates in the sense XOR gate cannot be used. In basic gates, what are the three gates that we are having? AND gate, OR gate, and the third one is NOT gate. So these are the three gates we have in basic gates. So only these three gates you have to use. If they ask you to construct using basic gates, means you have to use only AND gate, OR gate, NOT gate. Now let us see. Now for that you have to use sum expression is this sum expression we have to use. Okay, so first sum expression in the sense A bar B, AB bar we have no. First I will construct this term A bar B, I will construct, then AB bar I will take, then I will connect this A bar B AB bar with one OR gate. So I'll take A. A means A bar we have to give. So A, if you give to one NOT gate, it will give you A bar. So A bar is ready. Let me take B now. So A bar is ready, B is ready. So let's give to one AND gate. So this will give me A bar and with B. Okay, this is done. Now A B bar we have to construct. So A I will take, B bar in the sense, let's give this B to the NOT gate. Okay, now A is ready, B bar is ready here. A is ready, B bar is ready. Let's give to one AND gate, another AND gate. Now here A dot B bar it will construct, right? This is A, this is B bar. A dot B bar. Done. Now this term is ready, this term is ready. We have to combine these two terms using your OR gate over here, right? Plus means OR gate. So let me take these two signals, drag these two signals, use OR gate. So as we already know, this is the symbol of my OR gate. So this will give you A bar B, this term plus this term. What is this term? A B bar. Okay, we have constructed the sum expression. Now carry expression in the sense only we want A B bar. So let me take A from here and let me take B from here. Okay, take one 2 input AND gate. This will give you A dot B as a output. Now done, we have constructed sum. This is my sum expression and this is my carry expression of half adder. Now what is the condition why we have again implemented? Because we have to implement using only basic gates, that's why. So here we have used only basic gates, using basic gates. Basic gates in the sense, let me write here, AND gate we can use, OR gate we can use, NOT gate we can use, but we cannot use the XOR gate. So that's why in the place of XOR gate we have taken A bar A plus AB bar. So this is the circuit implementation if you use basic gates, and this is the circuit implementation if you use logic gates, right? And if they mention only logic gates, you can use anything, basic, universal, special gates, anything you can use. Okay, now this is one of the examples. So